I sat transfixed by a sea littered with a million fragments of ice, all rising and falling in time with the slow roll of the waves. We'd spent the morning looking for humpback whales in Wilhelmina Bay, threading our rubber boat between gargantuan icebergs that were tall and sharp, like overturned cathedrals. Now we stopped, cut the engine, and listened in the utter stillness for the lush, sonorous breath of an 80,000-pound whale coming to the water's surface. That sound would be our cue to close in. We had come to the end of the earth to place a removable tag on the back of one of these massive, ocean-going mammals, but we took nothing for granted in Antarctica. As we sat waiting on the small open boat, I came to feel more and more vulnerable, a speck floating in a sea of shattered ice. "Don't fall in," my longtime collaborator and friend Ari Friedlander deadpanned. I struggled to remember how long we'd been away from the Ortelius, our much larger oceanic vessel with its ice-hardened steel hull. In every direction, we were enclosed by a landscape of nunatucks, jagged spires of rock that pierced the creamy tops of surrounding glaciers. Where the glaciers met the sea, they ended in sheer, icy cliffs towering over the bay. Without a human structure for scale, these landforms seemed both near and far at the same time. This otherworldly scene of ice, water, rock, and light warped my sight lines, bending my sense of distance and the passage of time. If you hold your fist with your left thumb out, your thumb is the western Antarctic Peninsula, your fist, the Antarctic continent's outline. The Gerlache Strait is part of a long stretch of inner passageway along the outer side of Antarctica's left thumb, and Wilhelmina Bay cuts a rough cul-de-sac off the Gerlache. The Gerlache is a hotspot for whales, seals, penguins, and other seabirds, and Wilhelmina Bay is the bullseye. All come here to hunt for krill, small crustaceans that form the centerpiece of Antarctic ocean food webs. Consider your hand again. Individual krill are about the length of your thumb, but whales pursue them because they explode into great aggregations, or swarms, during the Antarctic summer. With the right mixture of sunlight and nutrient-rich water, dense clouds of krill form a sort of superorganism that can stretch for miles and concentrate in hundreds of individuals per cubic foot. By some measures, there's more biomass of krill than any other animal on the planet. Calorie-rich swarms of them lurk somewhere, not far, just under our boat. Where there are krill in sufficient quantities, there will be whales. But the problem with studying whales is that we almost never see them, except when they come to the surface to breathe or when we dive in our own limited fashion in search of them. Whales are inherently enigmatic creatures because the parameters of their lives defy many of our tools to measure them. They travel over spans of whole oceans, dive to depths where light does not reach, and live for human lifetimes, and even longer. In Wilhelmina Bay, our goal was to attach a sleek plastic tag to the back of a whale to record audio, video, depth, changes in the whale's speed, and even pitch, yaw, and roll. Our tags would provide crucial context for how humpbacks interact with their environment by relaying in a time-stamped way how they feed on krill. Ari and his colleagues have tagged and tracked whales along the Antarctic Peninsula for nearly 2 decades, charting their movements against the backdrop of changes in krill patch density, water temperature, daylight, and other variables. As climate change warms the poles faster than the rest of the planet, every year counts. I sat on the gunwale of the boat while Ari scanned from the bow. We were several days into a multi-week expedition with high hopes to tag as many humpbacks as possible, ideally a pod feeding together, but thus far we'd been skunked. Ari stood rigid like a figurehead, holding a 20-foot-long carbon fiber pole in folded arms. The pole flexed in synchrony with the swell, the teardrop-shaped tag bobbing at one end. I watched clouds shift slowly overhead, mirroring the dappled quicksilver of the water, and wondered whether any other place on Earth could feel as alien as Antarctica. Then, a loud gurgle interrupted my daydreaming, followed by a trumpeting blast of water vapor bursting from flaring, paired nostrils. A whale's blow. We knew to expect more plumes of water immediately thereafter. A pod of whales synchronize when they surface to breathe, sometimes nearly simultaneously or split seconds apart. They usually breathe a few times in a row, in quick succession, before resubmerging. Unless they're asleep or truly exhausted, whales tend to act like surfacing is a nuisance, and they'd rather be deep underwater. Their tight coordination in breathing likely has a lot to do with maximizing time spent below the surface, engaged in the cooperative tasks of finding food and avoiding predators. Some species travel or hunt in pods that are tightly knit family genealogies, while others, such as the humpbacks before us, form short-lived associations, seemingly a matter of happenstance.